Architeuthis.
Hello everybody, I'm Guy Cope with Architeuthis. Welcome to Machine Learning Mondays, the series where I break down advanced machine learning concepts and try to knock off some of the edges of buzzword to make machine learning accessible to all y'all. Today's topic: the confusion matrix measures performance for machine learning models. Specifically, it measures performance for classification models that have two or more classes. So things like fraud or not fraud would work very well in a confusion matrix. And the confusion matrix is essential to understanding performance metrics for machine learning models, which we're going to talk about in our next video. Unfortunately, no one can be told what the confusion matrix is. They have to see it for themselves. So that might be a little less dramatic than you expected. Essentially, a confusion matrix is a grid. For this grid, we're going to use two classes, but theoretically you could have many different classes to put onto a confusion matrix. In this case, the classes we'll use are positive and negative. The columns of the grid will be the actual values. These are the values in the data that a human would look at and say, this is what the answer is. On the row side, we'll have the predictions of positive and negative from the model. These are what the model says, yes, this is what the answer is. In general, positive outcomes are represented as a 1. In general, negative outcomes are represented as a 0. As we go through this, we'll actually learn about what's in each of these quadrants. But for now, the thing to remember is actual values, a human believes that's what's in the data. Predicted values, the model believes that's what's in the data. And then it's just a question of, do the model and the humans agree? Each quadrant in the grid has a different purpose. In this quadrant, in the upper left, this is a quadrant known as the true positive, or TP for short. Essentially here, the model has predicted that there is an actual outcome here that is good or bad, and the human looks at that outcome and says, I agree. So when the model and the human agree that the outcome is correct, then that is a true positive. In the opposite quadrant, in the lower right, we have a spot where the human has said, this should not be here, this is bad, and the model makes a prediction and says, this should not be here either. This is called a true negative. The human and the model both agree that the data here does not have any kind of correlation to the behavior sought to look at. So essentially, on these two quadrants, in the upper left and the bottom right, we have the true outcomes. And these are the outcomes that you want to maximize. With a true positive in the upper left being, yes, we agree, this is a positive correlation to the behavior I'm looking for in this class. And the lower right being, we agree that this is a behavior that we don't want to see for the behavior we're searching for, and therefore should not show up in our recommendations or predictions. In general, you want to maximize your true positives and true negatives as much as you possibly can. Outcomes in the upper right quadrant are called false positives, or FP for short. In a false positive, the model has made a prediction and said, I believe this behavior is relevant to the class we're seeking. Essentially, it's saying, this is the answer. In fraud, this might be the model saying, this is fraud. In sanctions, this might be the model saying, this is a name match. But if it's in the upper right corner, that means the human has looked at the result and said, this is not relevant. This has no correlation to the behavior that we're seeking. As a result, the human says this is a 0, and S should not be here. This is what's known as a false positive, because you have a model making a prediction that the human does not agree is accurate. In general, you want to minimize false positives as much as you possibly can. In the lower left, this is what's known as the false negative, or FN. Essentially, the model has said, this is not a behavior that's relevant. This does not belong in this class, you shouldn't have to look at it. And the human has taken a look at the data and said, this was relevant, I should have seen this, and the model has failed to give it to me. In the case of a sanctions model, for instance, this might be the model saying, there's no name match, this is not the person on the list. And the human might have looked at it and said, no, this is a match, this is a sanctioned individual. and it should have been queued. As a result, you want to minimize false negatives as much as possible. And the importance of false negatives and false positives varies based off the programs and the duties of your model. There are places where false positives matter a lot less than false negatives, and vice versa. But in general, you want to minimize your false outcomes as much as you possibly can, no matter what. So let's try to sum this up very quickly. The confusion matrix is a visual aid. It's there to help you understand how your model is performing in the simplest possible manner. You want to maximize your true outcomes, your true positives and your true negatives, as those are the outcomes that are desired. That means that the model and you agree that the item that it saw should be there or should not be there when it comes to looking for the class that it's going into. In general, false outcomes need to be minimized as much as possible. A false positive or a false negative means that you don't believe that the item should be there and the model does, or you believe the item should be there and the model doesn't. In the end, what you want to have is as few false negatives and few false positives as possible, with as many true positives and true negatives as possible. In the next episode, we're actually going to talk about the different metrics that actually show you how a model is performing. The reason we're going to do an entire episode on that is that this confusion matrix is essential to understanding these other measurements. And more importantly, each of these measurements has a different use. In general, just like the true positives, false negatives, and true negatives, you're going to want to maximize and minimize the same things, but what's the most important thing may change. So, quick, too long, didn't read, didn't want to watch the entire video. Maximize true positives, maximize true negatives, places where the human and model agree on the outcomes, and where the human and model say these belong in the classes that we've created. Minimize false outcomes, false positives and false negatives. These are the places where the model and the human disagree, and you want to minimize those as much as you possibly can. I hope you've enjoyed today's episode and you found it to be helpful. If you enjoyed the video, please leave a comment, like, and subscribe. And if you have more machine learning questions, and I suspect you do, remember, Architeuthis has you covered. See you next week.
Thank you for watching. Please like, subscribe, and leave a comment.